Hi everyone. In this video, I am going to explain about the Horspool algorithm. So it is another algorithm which is used to solve string matching algorithm. Already we solved the string matching algorithm by applying brute force technique. Let us see what is that string matching algorithm. Consider this is a character of text. Okay, this is a text and this is a pattern. So we need to search this pattern whether present this pattern in this text or not. This is what is string matching. That means we need to check whether this pattern is present in this given text or not. So generally we'll take text of some n number of characters and m number of characters in the pattern. So generally always we need to take the text and pattern in such a way that always n, that means size of the text should be greater than or equal to the pattern size. Okay, so in general pattern size is n, in general text size is n. Okay, now we need to search whether this pattern is present in the given text or not. In this example, I took 26 characters of text and 6 characters of pattern. Okay, so now how we solved this string matching algorithm by applying brute force? What we did, we aligned the pattern against the text from the beginning of the text. See, this is the beginning of the text. From the beginning of the text, we aligned this pattern against the text. Now what we did, we start comparing the characters. We start comparing the characters from the beginning, first character. First I check this first two characters. Now this is what? These two matches are J with B? No. This is mismatches. So whenever mismatch occurs, what we did, we shifted the pattern towards its right by one position. So whenever the mismatch occurs, we shifted this pattern towards its right by one position. So B A R B E R. Now it comes here. Now again what I will do, so again I will compare this this character with the corresponding character, the text pattern. So again these two characters are again what? Again mismatch occurs. Okay, again this is mismatch occurs. So what I will do, so again I will shift the pattern towards its right by one position. So now again I will do what? So again I will compare the first character of the pattern with the corresponding character of the text. So again here also it mismatch occurs. So like this, whenever the mismatch occurs, we simply shifting the pattern towards its right by one position. So like that I keep moving. So like that, how many times I need to move? So whenever a mismatch occurs, what we did, we shifted the pattern towards its right by just one position. So like that we shifted up to here. See, at this point of time it started comparing. So okay, this B with B, A with A. So that means see whatever I tick mark with the green. Okay, so here I find. So totally here, how many times we shifted the pattern? If we observe, this is the first time we aligned the pattern against the text. Okay, next up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Totally we shifted how many times? 16 times we shifted. 16 times. And how many times we compared here? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. In all these cases, mismatch occurs. 16 plus 6. So totally 22 comparisons we did here. 22 comparisons and 16 shifts we did. 16 times we shifted. 16 times we shifted. Or we jumped, I can say. What? We jumped the pattern. So that means the summary is this brute force string matching makes unnecessary shift. That means it makes just a little jump. Just is walking, not a jump also, only one step. Okay. So we can avoid this unnecessary shifting. That means we can, instead of shifting every time by one position, we can shift the pattern as far as possible. Instead of shifting one time, we can shift 3 positions, 5 positions, 6 positions, like that. We can shift the pattern towards its right as far as possible without missing any of the matching occurrences. That is the beauty of this Horspool algorithm. That means this Horspool algorithm avoids this unnecessary shifting of this pattern by shifting the pattern towards its right as far as possible. Okay, now let us see how much that Horspool algorithm is shifting the pattern towards its right, by how much position. So for that we are considering 4 cases.
Sorry.
This Horspool algorithm uses input enhancement technique. Input enhancement means before solving the problem, what we will do, whatever the given input is there, on that we do some operations and we will generate some extra information. Okay, and that with that additional or extra information, we can solve the problem in a faster way. So that's what the input enhancement. Again, this Horspool algorithm uses that input enhancement technique. So given the text and the given pattern of some characters, what this Horspool algorithm will do, it creates one table called shift table. It creates one table called shift table. So this shift table decides how much positions we need to shift the pattern towards its side when mismatch occurs. In brute force, we are shifting simply one position towards its side. But how Horspool algorithm makes more number of shifts, okay, more number of positions we are shifting. So how much that will be decided by the shift table. This is the additional information what this is generating. So with this information, we can reduce the number of shifts and as well as the number of comparisons when compared to what brute force. And now, in order to generate this shift table, we are considering the 4 cases. Okay, that means shift table decides what? How much distance we need to shift the pattern towards its side. That will decide the shift table. Okay, this shift table is constructed for all the possible characters present in both the text and as well as the pattern. Okay, now case 1. So the case 1 what? So in the case 1, so when mismatch occurs at the first time, when mismatch occurs at the at first position itself. At that time, how to shift. Now, let us take the same example. Suppose, for example, text. Assume text is something, text some characters are there, assume. And assume there is a character C. Assume character C and some text is there. Now, I'm searching what this one. So, barber. Okay. So now in brute force string matching, what we are doing, we are aligning the pattern against the text from the beginning and we are comparing the first character of the pattern with the corresponding character of the text. What the change in the Horspool algorithm, it will to align from the beginning only. But instead of starting matching from the first character, it starts matching from the last character. That's the only change from brute force string matching to Horspool algorithm. So now what it will do, it will check these two characters. That means instead of checking from the first character, Horspool algorithm compares with the last character. These two character matches, no mismatch occurs. When mismatch occurs, now we will see. Now here, which is the mismatch character of the text? See, this is the pattern. This character is mismatched with this character C and R, not same. So this is my mismatch character of the text. Now check whether this mismatch character is present in the remaining characters of the pattern. No. If the mismatch character of the pattern, mismatch character of the text is not present in the remaining characters of the text, so pattern, then shift the pattern towards its right by pattern length M. Here, what is the pattern length? 6. That means shift the pattern towards its right by 6. Okay, that means now I'm shifting to next one. So barber. See, now suppose in that case I'm shifting 5 times and then 6 times. Now I'm directly shifting by 6 positions. In brute force, every time shifting by 1 position. But here we are shifting by 6 positions. So when I'm shifting by 6th position, when the mismatch character occurs at the first position and that mismatch character of the text is not present in the remaining characters of the pattern, then shift the pattern towards its right by pattern length M. Okay, so at that case, that means if element is not found, in the case 1, if mismatch character not found, not present, then what you do? Shift by pattern length M, shift by M positions. Suppose now mismatch occurs at the first position only. Mismatch occurs at the first position only, but that mismatch character is present at the remaining characters. Okay, let us take that example. Okay, so now this is the first example, this is the first case. Okay, first example, the case one. Second one, so same thing, some characters are there. Assume now, say B is there, this is the B is the character. So now again, always we are matching with what? Last character of the pattern. So this is I'm matching. So these two matches, no, again mismatch occurs. But the mismatch character of the text is present in the remaining characters of the pattern. So now, again, why I took this example only, see there are two occurrences are there. P, two occurrences. Now what you have to do, the last occurrence, the first occurrence, second occurrence, the last occurrence of the character is at what distance to the last character of the pattern. Here, this is the last character of the pattern. So now, this B is at how many distance? Now this is at 1 and 2. 1, 2 positions. So now what I have to do? Now shift the pattern towards its right by 2 positions. So that means now 1 position, 2 position, now B comes here, A comes here, R comes here, B comes here, E comes here, R comes here. See now I brought my pattern towards its right exactly in such a way that that mismatch character of the text is aligned directly inside the what? Below the pattern. See this now if I compare these two, so now these two are matching, B and B. So I brought this B exactly below this mismatch character B. So this is what the second scenario in case 1. So that means again here also in both the cases what? Mismatch occurred at the first position itself. But here mismatch character is not present in the remaining character of the pattern, shift by pattern length. If it is present, you check at what distance it is there to the last character of the pattern. So now this mismatch character, that is B, is at a distance 2 to the last character of the pattern. So shift the pattern towards its 2 position. So this is 1, 2. So 2 position is shifted. So that means in this case, if it is present, mismatch character is present, then shift by what? Distance. To the what? Distance D to the last character of the pattern. So this is what the case 1. So hope you people understood. So now next case is what? Case 2. Now mismatch occurs after few successful comparisons. Okay. So now mismatch occurs after few successful comparisons. So you see, both mismatch occurs. In case 1, mismatch occurs the first position itself. But in the second case, mismatch occurs after a few successful comparisons. Okay, now at that time, what to do? Now let us take this example only now. Now let us take, this is my pattern, this is the text in the some text, okay, blah blah. So now, always we have started comparing from what end? We are comparing from the last end, right? So I compared the last two. Okay, these two matches, fine, come, next one, I'm coming this in the direction. Again, these two characters match, fine. Now when I come to this character, now mismatch occurs. Now mismatch occurs at the third character from the last. That means after 2 successful character has been compared successfully, then I found the mismatch character. Now this is my what? Mismatch character. This is my mismatch character. That means mismatch occurs after few successful. Here few means what? 2. 2 characters successful, then the third trial found. Now again check whether the mismatch character is present in the remaining characters of the pattern. No. So again the mismatch occurs. Again same thing, the first scenario in the case 1. If the mismatch character is present in the remaining characters, check. Now whether this character is present in the remaining characters, no. So again shift by what? Shift by what? If it is not present, mismatch character is not present. If the mismatch character is not present, again shift by what? Shift by pattern length M. That means again now you shift the pattern by pattern length 6. Pattern is 1, 2, 3, 4, 5, 6. 6 I'm shifting. This is exactly like case 1. So scenario 1 of case 1. Okay, so now let us take another scenario, the same thing. That means again if the mismatch occurs after few successful comparisons. Okay, let us take this example. Yeah. Now again, first I compared these two is successful. I compared these two successful. I compared this mismatch occurs. Now again, after few successful comparisons, mismatch occurs. Now if the mismatch occurs, now you check again whether that mismatch character is present in the remaining character of the pattern. Yes, it is present. The mismatch character is what? A. Whether that is present in the remaining characters? Yes, in the remaining characters it is present A. Now you check it is at a distance what? To the last character of the pattern. Now it is a distance what? This is 1, 2, 3, 4. It's a distance 4. So now 4. But out of 4, how many characters are already has been matched? 2 characters. So how many number of characters has been matched? Okay. The number of shifts minus that one. So that means now it is at the distance at the 4. Distance D minus matched character K. I will say K. K is the number of matched characters. The distance is what? So this mismatch character is at a distance 4 to the last character of the pattern minus number of characters has been matched 2. Okay, so in this 4 minus 2, 2. Now I shift the pattern towards its right by 2 positions. That means 1, 2. Now if I shift this like this, B, A, R, B, E, R. Now that means again I brought the mismatch character exactly below that one. See, I brought with now A below A only. See, now I brought A only. Okay, this is how we do. Okay, so this is what the actually totally 4 scenarios in 2 cases. Case 1 when mismatch occurs the first position itself. Case 2 mismatch occurs after few successful comparisons. If the mismatch character is not present in the remaining characters of the pattern, shift by pattern length. If it is present, check how many distance it is there. Generally minus number of character matches. Here no characters in match, shift by D only again. Okay. Otherwise, you should shift the pattern by the distance minus number of matched characters. So this is what the information, extra information, Horspool algorithm is generating. So this distance we are storing in a table format. That is what called shift table. Okay. Hope you people understood what is this shift table. Now, for this table, for this pattern, now I will consider the shift table. Okay. Now let us see how to construct the shift table for the given characters present in both the text and as well as the pattern. See again, we need to construct the shift table for both the characters present in the text and as well as the pattern. So for that, first write all the alphabets A to Z, and we are since we used underscore also, I use underscore. That means for all the possible characters you write. Now initialize this table with the pattern length. Initialize this table with the pattern value. The pattern value pattern length 1, 2, 3, 4, 5, 6. 6. Okay, so now I initialize all the characters with 6. That means all character values are 6. Okay, this is the first step in while constructing the shift table. Now you see, this is my last character in the pattern. This is the last character. Now you check remaining characters. Each remaining character is at what distance to the last character. So what distance to the last character. Now E is at a distance what? 1. E is at a distance 1 from to the last character. Okay, but suppose assume E occurs twice, always check the last occurrence. Okay, not the first occurrence. Okay, now E. That means now you update that E value. So E value here is what? Where is E? Now E value is what? E value is 1. Okay, so now look here. Now again, B. B is at a distance what? B is at a distance 1 and 2 to the last character. 1 and 2. So that means update the value of B by 2. Okay, B value is what? 2 now. Okay, see, now again, B occurs twice in the remaining characters. But this is the last occurrence. Don't take this one. You take the last occurrence. This is the last one. We always come from 1. So this distance is 1, 2, 3, 4, 5. But this distance is 2. Okay, take this one. Last occurrence. Now, again, similarly, now you take the R. Now R is at a distance. Now it is a distance 1, 2, 3. 1, 2, 3 at distance. Now you update the value of R by 3. R value is 3. Next, similarly, A. A is at a distance what? A is at a distance 1, 2, 3, 4. A is at a distance 4. So update the value of A by 4. Now, this is my shift table. Suppose if you are feeling this is too lengthy, you can reduce this into simple. Okay, so simple what? List down what are the characters are present. No, B is present, A is present, R is present, B is repeated, don't take, E is present, R is already there. Okay, only 4 characters, 2 are repeating, B is repeating, R is repeating, so I done only one, remaining A and B. Now, B is at a distance, now check, B is at a distance what? 1, B is at a distance 2, so B value 2. A value is what? 4. R value is what? 3. E value is what? 1. Other characters, other than these characters, what are the value? See, 6. So, pattern and 6. Now, in simple, this is my shift table. Whichever you feel easy, you that one. Either this one or this one. Okay, so both. Okay, this is what the shift table. Now, this shift table gives us the information about how much we need to jump the pattern as far as possible without missing any of the matching occurrence. Now we apply this Horspool algorithm. Okay, we done the input announcement. We got this additional information about the input. Okay, so now with this additional information, we will see how we'll solve this Horspool algorithm. Now again, first step is what? Align the pattern against the text from the beginning. From the beginning, we aligned. So now what I do? So always start comparing from what? The last character. I checked the last character. These two I checked. These two matches. False mismatch occurs at the first position. If the mismatch occurs at the first position, now check whether mismatch character is there or is there. Distance at what? Now check, get the value of A. What is the value of A from the shift table? Value of A is 4. Now shift the pattern by 4 digits. Okay. Now put this shift the pattern 1, 2, 3, 4. Now I bringing my pattern here. B, A, R, B, E, R. See now exactly I brought the pattern in such a way that mismatch character A I brought exactly below A. Now again you compare. From the last character of the pattern. So I'm comparing these two. These two again here what? Again here mismatch occurs at the first position itself. Now check, get the value of E. What is the value of E from the shift table? E value is what? 1. E value is 1. Whichever, both are same. E value is what? 1. Now shift the pattern towards it right by 1 position. So now what happens? Now my pattern comes to here. So now I'm comparing my underscore with the R. Now again, what? Mismatch occurs at the first position itself. So now again what I have to do? Now again we need to check the value of underscore. Underscore value is what? 6. Now shift the pattern towards it by 6 position. So that means, see, 1, 2, 3, 4, 5, 6. So that means now I brought my what? Pattern here. So now I am comparing what? The last character R with the B. Now again here what? Mismatch occur at the first position itself. Now again in the mismatch occurs first position, which is the mismatch character text B. Check what is the value of B. Value of B is 2. Now shift the pattern by 2 positions. Shift the value by 1, 2. So that means now my pattern comes in this position. See exactly now I brought my B exactly below B. Okay, now again compare R with R. These two what? First time now we got one character has been matched. One character has been matched. Okay, next compare the next corresponding characters of the both text and this one A and E. Now again in this case I got what? Mismatch. Now again you check whether A is there. Yes, what is the value of A? 4. Now how many times I have to shift? By 4? No. See, what is the value of A? The value of A is 4. But already one character has been matched. So shift value minus number of matched characters. How many number of characters has been matched? Only one character has been matched. So 4 minus 1, 3. Now shift the pattern towards its right by 3 position. So 1, 2, 3 positions. So now my pattern comes to what? B-A-R, B-E-R. So now if you compare this, see, now I compare this R with R matches, E with E matches, B with B matches, R with R matches, A with A matches, B with B matches. So here I found the pattern. So now if you observe how many shift I did, see this is the first time we aligned. First time I shifted from what? I shifted here from this position to this position one time. Next I position here 2 times. Now here to here 3 times. Here to here 4 times. Here to here 5 times. See earlier how many times? See here now shifted how many times? 5 times we shifted. By applying brute force, see how many times? 16 times. Where 16 times, where 5 times. See how much efficient this Horspool algorithm is. Okay, now check how many times we executed the comparison operation. One time we did comparison operation, 2, 3, so then 4, then 5, 6, 6 plus 6, 6. So totally how many comparisons? 12 comparisons. 12 comparisons. There 22 comparisons. So this is how Horspool algorithm works efficiently when compared to what? Brute force. See, the brute force makes unnecessary jumping just by one position. But this Horspool algorithm avoids that unnecessary jumping, unnecessary shifting. See, 16 out of 16, it eliminates 11 times. 11 jumps it will avoid, it will execute only do 5 times it will shifts instead of 16. So this is how it will avoid unnecessary jumping of the pattern. That means it is making shifting the pattern as far as possible. See, without missing any of the possibility of matching. Okay, so this is what, so not to shift how much position, so we are in the shift table. Okay, so this is how Horspool algorithm will work. Okay, let us see how to write this algorithm for this. Now let us see the steps to be followed in order to do this Horspool algorithm. First, what we did, first we constructed this shift table. What is the first step? First step is we constructed this shift table for the given pattern, and then second step what we did, we aligned the pattern against the text from the beginning. Okay, so that is second step. Now what we did after that, after aligning, we started comparing from the last character of the pattern with the corresponding character of the text. Okay, so until either all the characters has been matched or mismatch occurs. Whenever a mismatch occur, what we did, whenever a mismatch occur, we simply shifted the pattern towards its right by the shift value of the mismatch character of the text. This is what we did. So this we repeated until either we found the pattern or we reach the end of the text. Okay, this is what we did. Okay, the same thing what I have written. So in the this, see here, so first thing, the steps to be followed by Horspool algorithms are, for the given pattern of length m, we find the constructed the shift table. So then next what we did, next in the second step, we align the pattern against the text from the beginning. That we did. So then what we did, we repeat these steps, that means comparing and shifting the pattern until either we found the pattern or we'll reach the beyond the last cut of the text. So first we started comparing from what? See, from what? From the last character of the pattern which is the corresponding character of the text. Okay, that's what. So start comparing the last character of the pattern with the corresponding character of the text until all the characters, that means all m characters has been matched. Okay, or mismatch occurs. If mismatch occurs, what we are doing, so suppose here assume here mismatch occurs at the character A, mismatch character, we took the shift value of A and by that position we shifted, that is 4 position we shifted. Okay, this is what we did. If the mismatch occurs, we get the shift value of the corresponding mismatch character of the text from the shift table and shift the pattern towards it by that value, shift value. This is what we did. Okay, so now for these steps we will write the algorithm. First, before writing the algorithm for the Horspool, now we will write the algorithm to construct the shift table. Okay, so for that we will write the algorithm. Now let us write the algorithm to generate the shift table. So we need to construct the shift table for what? For the given pattern, right? So the parameter to be passed is what? The pattern to be for which we need to generate the shift table. So we generate, so parameter to be passed is what? Pattern for which we need to generate the shift table. So first, what we did the first time, so for that initially we initialized all the table entry with what? All the entry with what? 6. That means the pattern length. In this example, pattern length is 6 because there are 6 characters in the pattern, so pattern length. So initialize the table, shift table with the length of the pattern. Suppose if you take some other example, the pattern length may be 8 or maybe 9 or maybe 7 or maybe 4 or 3, whatever. So generally now we need to do what? Initialize the shift table with the pattern size m. Okay, so in this example 6, that we need to do that. So that's what I written. So initialize all the elements of the table with the pattern length m. That's what we did. The first step is over. Next step what? Next step, now I need to calculate for each character. So we are started from the first character. So now I took the first character of the pattern B. So B is at a distance what? To the last character. See, B is at 1, 2, 3, 4, 5. B is a distance 5 to the last character. So we'll update the shift table. So B, now I'm writing here first. So B is a distance 5, right? So next I took the character A. Now A is at a distance what? 1, 2, 3, 4 to the last character. So A is at the last distance. So the shift value of A is what? Shift values of A is what? 4. Similarly, now I have to take the next character. Now the next character is what? R. Now R is a distance what? Now R is a distance 1, 2, 3 is a distance 3. So I will update the shift value of R as what? 3. So next value of the next character of the pattern is what? B. So now B is a distance what? 1, 2. So now we'll update. Earlier B is 5, but we have to take the last occurrence. That's why I told. Now B is a distance what? 2. So okay, the shift value of B is 2. So the next character of the pattern is what? E. So E is a distance what? 1. So we'll update the shift value of E as value of E is 1. So now that's the same thing what? See, shift value of B is what? 2. See, that's what B value, shift value 2 I got. A value 4. See, A value 4. Then R value what? R value is 3. See here R value is 3. Here E value is what? 1. So E value is 1. Okay, this is how to construct the shift a table. Okay, so for that this is what we did. Okay, so first from the first character, that means we started from which character? First character means what? I took the index J here. Okay, next this is my J. Next J is my what? This is my J. Next this is my J. This is my J. That means I started taking J from what? 0, next 1, next 2, next 3, next 4. That means I stopped taking the characters, first character, second character, third character, fourth character, fifth character, and not take the last character. That means I need to repeat this from the first character to the last but one character. Last but one character means what? This is pattern of size m. The last one is m minus 1. This is what? M minus 1. So this is m minus 2. Up to that we need to stop. So we started from what? We started J from what? 0 position. So I'll write for J is equal to what? 0. To what? I stopped at what? Last but one position. If you see, J is equal to 0, B, then J is equal to 1, that is A, then next R, next B. See, that's what this J, B, A, then R, then B, then this one. Last but one cut. Last but one cut is what? M minus 2. So this is J is equal to 0 to what? M minus 2. What I have to do? Now I need to calculate the distance. Okay. Now I have to update. So what is the name you have given? I have given the name of the table as table. So table of what? Now pattern of J. First character of this one or J is equal to 0. Now pattern of J. Pattern first one. Pattern of J is what? B. B is at what distance? Now B is at J value 0. The last character is 5. So 5, right? 1, 2, 3, 4, 5. So that means M minus 1 minus 0. Similarly, see here the last character is M minus 1. M minus 1. This is index minus 1. This is 4. 1, 2, 3, 4. See, this is 5 at a distance 5. These are the distance 4. These are the distance 3. These are the distance 2. These are the distance 1. If it keep decreasing, if you see, it's at the 5, 4, 3, 2, 1. So that means m minus 1, 5 minus 0, 5 minus 1, 5 minus 2, 5 minus 3, 5 minus 4. In general, m minus 1 minus j. So what I have to do, this table of p of j, I need to update with what? So table of pattern of that particular character, distance is m minus 1 minus j. That's it. Now, okay, that is the end for, and then finally I need to return what? The table. This is my output table, okay. So this is the algorithm just to generate the shift table. That is what our first step, okay. Shift table. Okay, this is the shift table what we generated. So to generate this shift table, I have done this algorithm, okay. Hope you people understood. Now we will discuss, Horspool algorithm uses this shift table to shift the pattern towards its right by the shift value of the mismatched character of the text. That we will see. So name of the algorithm I have given as Horspool. You can use any other name. So this is just naming. This is the function name I have given. And the pattern for which we need to find in the given text. These are the two parameters to be passed. Now, what is the first step? So, first step is what? We need to generate the shift table. So, for that, already we written the algorithm. This is what our shift table algorithm. Now, we need to call this function to generate the shift table. So, I will call this first function to generate the shift table. So, my statement is, first I am calling shift, that is the name what I have given. Use the same naming convention, shift table, okay. And what I have to pass the parameter, I need to pass the parameter what? Pattern to be search, okay. This is what I have to search, okay. This is the first statement. That means I call the function shift table. See, this is the name I have given, the shift table, shift underscore table is the name I have given. So I'm called this function in my Horspool algorithm, okay. So this is done. So next what I have to do, so now after that, what is the next step? We need to align the pattern against the text from the beginning, and we started comparing from what? From the last character of the pattern. So last character of the pattern is what? M minus 1. So what is the last character of the pattern? So this is the M minus 1 in general. In this example 5, but not always. So last character of the pattern is M minus 1. So I initialize my index, one index. So that is, let us take I. That I am indexing as m minus 1. This is, I marked the last character of the pattern. Now this character, I should keep comparing with the characters till my pattern is reached the last character. Last character of the text is what? N minus 1. So I don't know when I will find. So I will use while. And then this while I is less than or equal to n minus 1, I need to repeat all these things. So what I have to repeat? So first, initially, when I align the pattern against the text, initially how many characters? Initially we are still not yet we compared. So no character has been matched. Okay. So number of characters is matched. For that I am taking the one more variable called k. Here k indicates the number of characters matched. So initially how many characters are matched? Initially 0. Okay, k is equal to 0. This many number of characters has been matched. Now that k should be what? Number of characters of the pattern match. That should be always less than or equal to what? M minus 1. Okay. So I will use while k number of characters is less than or equal to, that means still some more characters are there in my pattern, and okay, logical operator, and now it is a pattern of, that means last character m minus 1 minus k. Initially k is 0. That means last character I am matching with what? I am checking this is equal to the text of, that is what again. I took the again same thing, m minus 1, the last character. Okay, corresponding character. I minus k. If these two are equal, that means character has been matched. If character has been matched, what? I am incrementing k. So again, k I took for what? Number of characters matched successfully. Okay, if these two matches, one character has been matched. So then what? Then I have to come to the next characters. Okay. So after that, I'm keep incrementing. If it is lesser than m minus 1, keep checking. I'm keep incrementing. Whenever this condition fails means what? Whenever the mismatch occurs. Now I need to check whether number of characters has been matched is equal to the pattern length. That means whether I matched all the characters of the pattern with this one, I'm checking. If this is true, then match is successful. That means we found the pattern. So I'm returning I minus m plus 1. That means I was initially m minus 1. So minus pattern plus 1. That means that index, starting index. See, I'm coming from the last index, coming from the last one. Okay. After that, I'm coming here. Okay. So then last one, I minus 1 minus m1 only, plus 1 means I get this index. So this is the index. To get that index, this is what the formula. Okay, I minus m minus 1. If all the characters of the pattern has been matched. If this is false, means some more characters are there, but mismatch occurs. So at that time, what I have to do, I need to take the shift value of the mismatch character of the text, and by that shift value to shift. Okay, so that means whatever now I'll take the shift value from the what? Table of what? Text of I, because see, T of I indicates what? Text, mismatch character of the text. So that shift value I'm taking from this table, and that I'm incrementing with I value. Okay, so that I'm updating as a new value of I. Else you do this one, shift this one. Now this is what? Shifting the pattern towards its right by the shift value of the mismatch character of the text. Okay, so that's it. End if. Okay, end if. So after that, so this we need to keep continuing as long as we have still within the text. Once we read the end of the text, we stop. So end while. After that also we not find, then simply return what? Minus 1 indicate match is not successful. That means pattern is not found. Okay, this is what the algorithm. So for this Horspool algorithm. So first we call the shift table. We initialize to the last character in the text for the I for the text. Okay, so then from the last character, okay, I'm comparing. So k is indicates the number of characters has been matched. So as long as it is matching, I'm incrementing k. So once again the condition false comes out, I'm checking whether all the characters have been matched or not. If it is matched, all the characters match is successful, and need to return the index of the text. So I minus m plus 1. Otherwise, shift the pattern towards its right by the shift value of the mismatch of the text. Okay, otherwise return minus 1. So this is the complete algorithm of what? Horspool algorithm. So hope you people are understood. Thank you. Thanks for watching. If you have any comments, please write it in the comments box. Okay, thank you.